Senolytic drugs, which are designed to selectively eliminate senescent cells, represent a promising new approach in the fight against aging and chronic disease. While they don't directly lengthen telomeres or activate telomerase, their role in maintaining tissue health and reducing telomere-related damage is both profound and increasingly supported by research. Senescent cells arise when cells reach a critical point of damage or exhaustion, often due to shortened telomeres, oxidative stress, or repeated replication. These cells enter a state of permanent growth arrest to prevent malignant transformation, but they don't quietly disappear. Instead, they linger in tissues and release a barrage of pro-inflammatory and tissue-degrading signals collectively known as the senescence-associated secretory phenotype, SASP. This chronic inflammatory environment not only contributes to local damage and degeneration, it also promotes further telomere erosion in neighboring healthy cells. SASP factors increase oxidative stress, disrupt stem cell niches, and interfere with normal tissue regeneration. In this sense, the presence of senescent cells becomes a self-propagating cycle. Telomere shortening leads to senescence, senescence leads to inflammation, and inflammation accelerates telomere loss in nearby cells. Senolytic drugs, by targeting and clearing these dysfunctional cells, break this cycle at its root. Compounds like dasatinib and quercetin, two of the most studied senolytics, have been shown in animal models to dramatically improve physical function, reduce inflammation, and even extend lifespan. In aged mice, periodic treatment with these drugs resulted in better muscle strength, improved cardiovascular health, and enhanced insulin sensitivity, all outcomes that suggest a reversal of age-related tissue dysfunction. Importantly, treated animals also displayed lower levels of circulating inflammatory markers and reduced oxidative stress, which suggests that the remaining cells were less likely to suffer telomeric damage moving forward. There is also evidence that clearing senescent cells improves the regenerative capacity of tissues. Stem cells, which are critical for maintaining organ and tissue function, are highly sensitive to their surrounding environment. When senescent cells are present, stem cell activity is suppressed and new cell growth is impaired. By removing these aged, non-functional cells, Senolytics restore a healthier signaling environment that promotes stem cell proliferation and differentiation. This rejuvenated activity reduces the replication burden on somatic cells, slowing the rate at which telomeres are consumed. Another important point is that Senolytics may reduce the systemic burden of inflammaging, the chronic low-grade inflammation that increases with age and is strongly associated with telomere shortening. By reducing this inflammatory load, Senolytics indirectly protect telomeres from oxidative assault and may help preserve genomic integrity. Unlike broad-spectrum anti-inflammatory drugs, Senolytics act upstream in the aging process, targeting the source of inflammatory signals rather than merely suppressing their effects. Preliminary human studies are beginning to echo these findings. Small-scale clinical trials in patients with idiopathic pulmonary fibrosis, a condition associated with both telomere dysfunction and cellular senescence, have shown that intermittent dosing with Senolytics improves physical function and reduces biomarkers of inflammation. Though still in early stages, these results offer compelling evidence that Senolytics could play a vital role in human anti-aging strategies, especially for preserving organ function and cellular integrity into advanced age. Importantly, Senolytics are not meant to be taken continuously. Their intermittent use, perhaps once every few weeks or months, appears sufficient to reap the benefits without overburdening healthy tissues. This is a key safety consideration, as the goal is to selectively clear only those cells that are truly senescent, not disrupt the body's normal healing or regenerative processes. The synergy between Senolytics and other longevity-promoting strategies is another exciting avenue. For example, combining Senolytics with telomerase-activating therapies could amplify benefits. The former clears damaged, inflammatory cells, while the latter restores proliferative capacity to those still functional. Similarly, Senolytics may pair well with mTOR inhibitors, intermittent fasting, or hormetic compounds, helping to create a comprehensive cellular environment optimized for health span extension and reduced biological wear and tear. In conclusion, Senolytic drugs offer a highly targeted, strategic way to manage one of the key drivers of aging, senescent cells with critically short telomeres and toxic secretions. By removing these dysfunctional cells, Senolytics reduce inflammation, restore tissue function, and lower the cellular stress that accelerates telomere loss. While not a direct telomere therapy, their impact on the broader ecosystem of the aging body could make them a central pillar of future regenerative medicine and longevity science. As research advances and these compounds are refined for greater specificity and safety, they may help millions maintain vitality and cellular integrity well into later life.